Hello everyone, I'm Akshat Mishra and this is my ZID Z5461265 and this is my final video for the Introduction to Astronomy Classifying Galaxies experiment. In this short presentation, I'll be taking you through how galaxies form, how we classify them using real data, and what this reveals about their evolution across time. Now let's begin with our current understanding of how galaxies form and change. Galaxies begin as massive clouds of gas that collapse under gravity. Over billions of years, they evolve through internal processes and interactions like collisions or mergers. Spiral galaxies tend to be rich in gas and dust, forming stars actively, whereas the elliptical galaxies contain older stars and result from mergers. Hence, they are more passive in terms of star formation. Irregular galaxies are chaotic and often reflect earlier stages of galactic evolution. In the early universe, galaxies were smaller, more irregular, and more dynamic. Over time, through mergers and environmental effects, they matured into the stable structures we see today. Now let's talk about colors. Colors are a key clue in the classification of galaxies. In both the Coma and the Hercules clusters, spirals appeared blue, which is a sign of hot young stars forming in their arms. On the contrary, elliptical galaxies were yellow to orange, indicating an older stellar population and minimal star formation. I compared bulges and disks in spiral. The bulges were redder, showing older stars, whereas the disks were blue, where the new stars were forming. So color tells us about stellar age and where star formation is still active. Now let's talk about interactions. Like in the galaxy NGC 6745. In this image, we see bright blue patches, especially in the tidal tails. These are newborn stars formed by gravitational compression during galactic collision. This shows how interaction drives starbursts and reshape galaxies, forming tails, bridges, and even using Galaxy Zoo, I classified several galaxies. Ellipticals were found to be round, smooth, and structureless, whereas the spirals showed distinct arms, bars, or edge on disk. From the three galaxy clusters I analyzed, I found a dominance of ellipticals, a few spirals, and some irregulars. Whereas in the Hubble Ultra Deep Field, where we observed the earlier epochs, I classified around six spirals, nine ellipticals, and five irregulars. The deeper field had more irregular spiral galaxies, supporting the idea that galaxies evolve over time from chaotic beginnings to ordered structures. This comparison right here reveals a powerful insight. Dense clusters today have mostly elliptical galaxies, the result of frequent mergers and aging. But in the early universe, observed in the ultra-deep field, we see galaxies in more active, less evolved states, which are the spiral and the irregular shapes. This aligns with our models of galaxy formation and evolution. Interactions, environment, and time shape galaxy architecture. Denser environments accelerate evolution, leading to passive older galaxies. Now, what if we took a new image of the Hubble Ultra Deep Field 10 billion years from now? We'd likely see a dimmer, redder universe, fewer star-forming regions, some galaxies which are no longer visible due to redshift beyond our horizon, and a shift towards more elliptical and fewer blue spirals. The universe in general would be calmer, and the cosmic cycle of galaxy evolution would be further along its path. I conclude my presentation. This experiment taught me how galaxies are classified by shape, color, and structure, and how we can use real observational data to uncover deep insights into cosmic evolution. I learned how to apply tools like the Hubble tuning fork and the Galaxy Zoo, and I gained a strong appreciation for how citizen science contributes to real research. Galaxies are not just distant objects, they are dynamic living systems that tell the story of our universe past, present, and future. Thank you all for watching.